Welcome back to the Sage Audio channel. Today we'll cover how to use subtractive equalization during mastering. We'll discuss subtractive equalization in general, when you should use it during mastering, and some of the more advanced details that you should keep in mind while introducing it to your master. We'll also listen to examples throughout, so if you could, like, subscribe to the channel, and stick around for the full video. But first, if you're an artist, engineer, or producer, and you have a mix that you need mastered, send it to us at sageaudio.com. We'll master it for you and send you a free mastered sample of it. All you have to do is set up an account, upload the song, and we do the rest. Subtractive equalization is incredibly simple in theory, but in execution, it can be a little more complicated. Subtractive equalization is the use of an equalizer as a means to attenuate various aspects of the frequency response. In other words, you use an equalizer and you cut out the frequencies that don't sound good. But choosing these frequencies, how to attenuate them, and when to attenuate them can be the tricky part. With that in mind, let's answer the question, when should we use subtractive equalization during a mastering session? Subtractive equalization is best introduced very early on in the signal chain of a master. The reason being, other forms of processing like saturation, harmonic excitement, compression with makeup gain, and of course additive equalization and limiting can make unwanted frequencies louder and in turn harder to tame. Now, that's why I almost always start my mastering signal chain with subtractive equalization. This way I can attenuate aspects of the response that I think might cause issues further down the line. This includes, but isn't limited to, excessive low-end frequencies, aggressive sibilants, and subtle discordant frequencies that detract from the enjoyability of the sound. In other words, keep in mind what you don't want to become more aggressive with the subsequent forms of processing. This will give you a great idea as to what to attenuate. What you attenuate can be on your mid-image, your side image, stereo, or left-right images. So for example, if the mix has a guitar panned hard right, and you notice an unpleasant scraping sound when the guitarist's fingers move up across the strings, you should isolate that frequency on the right channel and then attenuate it. Another example that I always like is attenuating bass frequencies that make their way into the side image. By attenuating the side image with a high-pass filter, you can make your low frequencies mono. One more good technique is to cut frequencies out that are below 15 Hz on the mid-image. Now, this won't make a perceivable difference to the master, but it'll give you slightly more headroom to work with later on. Let's listen to the effect that subtractive equalization has on a master.
Something in me stay. Let me let go and let me let go and let me love again. Let go and let me love, let me let go and let me love, let me let go and let me love again. Let me let go and let me love, let me love, let me love. Again.
Next, let's discuss how and when to use dynamic subtractive equalization. Dynamic subtractive equalization is great for when you want to attenuate an aspect of the signal, but only when it's aggressive enough to trigger your dynamic EQ's band. Subtractive dynamic equalization is often used to control vocal sibilants and other narrow frequency bands during mastering. If your equalizer is capable of dynamic equalization, this can be a great addition to the subtractive equalization stage of your master. Now, the primary thing to keep in mind when you're using this type of processing is that it shouldn't cover a wide area or bandwidth. Typically speaking, it's best for this type of subtractive equalization to handle a small set of problem frequencies, and not to be used as a means of drastically changing the frequency response. The same goes for standard subtractive equalization during mastering, but I could foresee this effect being overused. Let's listen to the effect that dynamic subtractive equalization has on a master.
Was a mistake, but let go and let me love, let me let go and let me love, let me let go and let me love again. Let me love, let me love again. Let go and let me love, let me let go and let me love again. Let go and let me love, let me love, let me love again. Let go and let me love, let me let go, let me love again. Let me love, let me let go and let me love, let me love again. Let go and let me love, let me let go and let me love, let me love again. Let me love again.
Last up, let's talk about how phase relationships affect subtractive equalization. Destructive interference, or masking, is the process of a louder signal covering up or canceling out a quieter one. When performing subtractive equalization, this concept plays an unexpected role in which frequencies to attenuate, how much to attenuate them by, and possibly how to attenuate a frequency by amplifying another. When using an equalizer, we're really just playing with phase cancellation. Equalizer bands work by inverting the phase of a part of the signal and then combining it with the original signal in order to attenuate it. That said, understanding phase relationships can be a big part of understanding subtractive equalization. Now, the primary thing to consider is how lower frequencies mask or cover up the frequencies directly above them. For example, a 100 Hz wave will mask some of the amplitude of a roughly 300 Hz wave, and so on. As you can imagine, this makes that 300 Hz wave a little less perceivable. Following that idea, we understand how intertwined all of these frequencies are. There isn't one set that stands alone or doesn't really affect another. Fortunately, we can use this knowledge to our advantage. So let's say that we want that 100 Hz wave to be more present. What could we do? Well, the first reaction would be to amplify it, but this has two big implications. First, that 100 Hz wave would then mask what's directly above it, as we just discussed, which may or may not be something that you want. Secondly, that 100 Hz wave is now running into the next stage of processing a little more aggressively. For example, if the next processor is a compressor, then 100 Hz will play a more significant role in how much is compressed and when the signal triggers the compressor. Again, this may not be something that you want. Instead, what we could do is attenuate frequencies below 100 Hz. This will make 100 Hz more prevalent without the two issues that we just discussed. Conversely, if we wanted a frequency to be less prevalent, say 300 Hz, we could amplify 100 Hz to make it less prevalent. In this example, we strangely get subtractive equalization by using additive equalization. Now, of course, this will make 100 Hz more prevalent as well, and potentially cause more aggressive processing from the next insert in your signal chain. Now, all of this is a bit complex and a little more advanced, but it's something to keep in mind when you're mastering and performing subtractive equalization. Let's try to hear how phase cancellation affects other frequencies. This is going to be a little difficult to discern, but listen intently and you'll notice very subtle changes.
It's a mistake, but I can't move on with something in these days. Let go and let me love, let me let go and let me love, let me let go and let me love again. Let go and let me love, let me let go and let me love again. Let go and let me love, let me let go and let me love, let me love again. Let go and let me love, let me let go and let me love again. Let me love again. Let go and let me love, let me let go and let me love, let me love again. Let go and let me love, let me let go and let me love again.
So let's sum up everything that we just talked about here. First, it's usually a good idea to use subtractive equalization as the first insert when you're mastering. This prevents you from augmenting any aspects of the frequency response that you don't want augmented. Furthermore, you can use mid-side and left-right channel targeting to attenuate frequencies in specific areas. This will result in more accurate and purposeful attenuation. If you have frequencies that you want to attenuate, but only at certain points, try dynamic equalization. This can be useful if maybe a bass guitar is making things muddy, or if the vocalist sibilance is too aggressive. Lastly, phase cancellation or masking is a huge part of subtractive equalization and equalization in general. Keep in mind that lower frequencies mask those that are higher than them, which inevitably affects how you should equalize, what you should attenuate, and what you should amplify. So, these are our thoughts on subtractive equalization during mastering, but what do you think? Is there something that we covered here that you'd like to learn more about? Let us know in the comments section below. Also, if you're an artist or an engineer, send us one of your mixes at sageaudio.com. We'll master it for you and send you a free mastered sample of it. All you have to do is set up an account, upload the song, and we do the rest. But thank you so much for watching. We really hope you enjoyed it. If you did, please like and share this video with your friends. This way we know if you'd like to see more videos like this one. Also, you can subscribe to the channel. We release new videos every week, and subscribing is the best way to stay up to date. There's a comment section where you can leave your thoughts on this video, or you can make a suggestion for a future video. And again, if you're an artist or an engineer, and you have a mix that you need mastered, send it to us at sageaudio.com. We'll master it for you and send you a free mastered sample. Thank you so much for watching. We'll see you in the next video.